diligently entering. I'll slide this up halfway. Do you guys want a fee quiz for next week? Maybe like an extra quiz to talk about where fee is, like go find places where fee is. That'd be a fun quiz, wouldn't it? Go find at least 4 or 5 places where fee exists. Go to a garden, go to Greece. Yeah, we'll do that. Well, essentially it will act kind of like that.
What did you ever do for that one that we did that was a 243?
I don't know. They're still sitting at my desk waiting for me to figure out what to do with them. Unfortunately, I have so much other crap to deal with right now, and I keep putting it back because I don't know what to do with that. I'll figure it out. So, y equals something x plus something. It's going to be plus something, I think, inevitably. Where x is a.
Because that's there.
So I'm waiting for the model to finalize. I'm waiting for the model to finalize as you guys enter your data. Watch out there. So you notice it's changing. I'm not going to put the A and the B values, or the slope and the y-intercept values in just yet, because I'm kind of waiting to see what happens as you guys put your data points in. Now you see what's kind of cool about this data? It's a lot messier than the data we just looked at with the earnings. And it's a lot messier than the uninsured data that we looked at last week. Look what just happened there. Oh, those are backwards. Yeah, 7 and 10.5.
But you said it was earnings that they had crunched it to make it look like that.
They had crunched it to make it look like that.
Yeah, you said the line.
Oh, because they made them look, but even when we adjusted it though, Shelly, we put in the correct year values, it still was essentially linear.
Yeah.
But it was so neat. Like whenever I see data that's that perfect, I sit back and I'm like, I think it Harrison Ford and the Fugitive. It looks too good, right? Because it looks too good. This data makes me stoked because it's messy. It's messy. But do you see it's showing a trend? It is trending upward though, isn't it? It is trending upward.
7 inches.
Say that again?
A lot of people have 7 inches.
Yes. Now, I want to talk about this data too. There's a potential concern we should have with this data. I'm trusting that you guys are measuring yourself with good precision, right? I've noticed I handed you a tape that has 16th inch markers on it. No, I lied. 1/8 inch markers on it. And the only eighths that are showing up there, somebody did it, 7.63. That's 7 5/8. That's 7 5/8 rounded. Everybody else is going, oh, there's a quarter. We got 2/8, 6.25, 6.75. Very few of you are actually using the eighths, it sounds like. I find it very hard to believe that all you guys are exactly 7, exactly 7.5, things like that. Am I pissed about this? Hell no. I didn't tell you to use all eighths. But it's one of those things. There might be different results because I'm basing the measurements on you guys taking the measurements. When we get into statistics, we'll talk about this more and the dangers of what are called self-reported samples, which is essentially what this is. It's a self-measured sample, but it's self-reported. If I wanted more precise results, what would I have to do?
Measure yourself.
Well, either myself, if I'm qualified,
Or one person.
or bring somebody in who is a qualified measurer of forearms and wrists and have them do it for me. This is why I go to Jenny Cruikshank. I want to know what my body fat percentages is. I can do that. Or I can go to her with calipers. She takes three hits. She averages them together. Shelly's looking at me like, why the hell would you do that? I'm interested. And sometimes I like to track the trends, see if things I'm doing in my diet are actually paying off. So anyway, the point is that I can test myself, but the data that I get, I can feed into a chart just like this. But the trick with it is, if I did that, that puts a lot of faith in the measurement I just took to see if it actually makes sense, if that's believable. Okay, we got our data. Now there's our best fit line. That's the best fit line. I'm not going to have you guys put all these data points in your TI. I think you know how to do it now. That's why I had Excel do it. What do you think? If you looked at this data, hang on, let me delete it here. That data right there, would you, it does not look as neatly linear as the other 2 sets we looked at, does it?
Well, it looks like it's trying to communicate with us.
It looks like it's trying to communicate with us. I love that.
Let's play that.
Let's play that.
Yeah, musical.
Oh, musical! I got you. Like chords. Chords. I like that very much. That's interesting. That's interesting. There are folks that have the same A value, but different B values. There are also folks that have the same B value, but different A values. That's interesting, isn't it? And that's variability. That should be the case. If this data came up like this, I would want to take a look at all your arms. Like, what the hell's going on? Why am I seeing perfect data? It shouldn't be perfect. It should be noisy like this. Now, just to put your minds at ease, in 244, we're going to attack something called the correlation coefficient, which I can add to this curve. I think I can do it. Just go into layout, trend line, or trend line options, display R squared value. Boom. That guy right there. Now, this is not going to mean anything to you right now. It won't mean anything to you until math 244. But that number tells me that even though the data is fairly scattered, it's still rising enough left to right predictably linearly to be considered linear data. The more data you put into this chart, the more variance you're allowed to have, because it makes up for those natural variances in our body that are automatically naturally going to be there. Does that make sense? Am I recording this? Is that recording? I think we are.
It's
right?
red, yeah.
It's red. Awesome. Thank you. Does that make sense? The R squared value should not. That shouldn't make sense at all to you. That's okay. But as far as it's linear enough, and this goes back to Tori's concern, if it doesn't look linear at all, don't sweat it, sister. I will tell you. Here's some data. Find me a linear model. Is that fair? Now, here's the deal. Here's the deal. Our model now is about, well, I'm going to call that 1 to go with you guys. 0.98, I'm going to round it off to 1. So y equals x plus 3.7. I'm calling the slope 1. I'm calling the slope 1. So what does that mean if the slope is 1? Up and over 1. Perfect. 45-degree angle. It's up and over 1. It's a little bit hard to see the 45-degree angle. Let me change the axes so you can see it better. I'm going to fix them. 6 to 13. Let me make this go. Hang on. Let me fix this axis to go 0 to 13. Let's make this axis go 0 to 13 as well. There. There. There's your 45. It somehow cut off at 12. No, they're 13. There's your 45-degree angle. It's not quite rectangular yet. Let's make it square. There. That's more square look. This happens all the time with the TIs. When you do a graph in the TI, it's a rectangular window, so it's lines that are sloped at 45 degrees look much shallower. That's how steep the line actually should be.
That's a serious grade.
Say that again?
I said that's a serious grade.
That's a serious grade. You will not drive any roads that graded like that in this town. The steepest road, did anybody hear, if you watch the video on YouTube about the triangle, I found, I think, the steepest road in Bend. It's called Palisades. It's right off of my commute. I saw it the other day, and I looked down, I'm like, holy F, and I went down and drove it. And from the side, it looks like that. It's not that steep. I think it's 20, I forget now. I want to say it's 28%. It's ludicrous. It's ludicrous. Anybody that lives on that road, stay home when it snows. Seriously. Because if you switch to come out of your driveway, you're going to kill someone. Probably yourself. Anyway, this is very steep. What does the slope tell you? The slope is 1. It's effectively 1, right? So, what does that mean about this length and that length? It's an exact 1-to-1 ratio. It means that on average, this part of our arm is the same as this part of our arm. That's what that data says on average. Now, I'm looking around the room at you guys, and I don't see anybody with Michael Phelps hands or T-Rex forearms. Right? I heard the T-Rex forearm is quite good, actually, by the way. But what's happening is that we're getting all this goofy variation. Some of us have slightly longer hands than forearms. Some of us have slightly longer forearms than hands. And on average, it's beginning to balance itself out. You notice how there are some points below and some points above? And they're canceling each other and resulting with a 1-to-1 ratio, essentially. Actually, 0.98 is the ratio of B to A. That would actually mean our hands are a smidge bit longer than
How is that even possible with all those numbers?
because it's averaging out to cancel. That above and below. Now what I did, thank you Andrew, what I've done historically, let me grab it over here, is I've got lots of data, because I'm me. I've got every single time, let's drop these guys in here as well. I've got lots of data to play with. This is the last 2 times I collected the data, I think. And this, I believe right here is you guys, yeah? That's you guys.
You missed it.
I did?
No, you got it.
Oh, maybe.
Did I get it? Oh, I just didn't get the labels. And this, that's belly button. The belly button ratio is even worse. I don't bother doing that one. Plus, it's a little too PG for class. There. There. Now look again.
Yeah,
The slope is now worse than ours as far as we're expecting B to be longer than A. You see what I'm getting, Andrew?
I'm still confused because in none of the measurements that you have up there is B equal to A. So how does it average close to that?
It's just the fact. Look at these here. Look at these here. In here, this is a 1-to-1 ratio. Essentially, it's not 1-to-1 anymore. But these guys right here, this means on average, this measurement is longer than this measurement. For example, this guy right here, 6 is, oh, that's 8. It's off again. It's off again. It's off again. It shifted up by 4. That's the problem right there. It shifted up by 4.7. My apologies. My apologies. The ratio is 1-to-1, but the plus 4.8 inches gives us the extra length that we needed. But that's not what I'm concerned about. What I'm concerned about is I kept hearing over and over again how, on average, the ratio of B to A is this golden ratio 1.6. I'm getting that it's half of that historically. I'm getting that it's half of that historically. So my problem is that I don't even know who's making the claim that it's a 1.6 ratio because it's not showing up, at least in my students. Maybe COC's students are different. Maybe we have a different golden ratio. It's half the golden ratio, half phi, I don't know. I don't know what it is. But that's what I like. I like seeing this data laid out like that. Thank you, Ed, for pointing that out. I was fixated so much on the ratio, I wasn't looking at the plus 4.8, which means on average we add 4.8 inches to this to get this. Now, I didn't come here to tell you that either. Somebody said something about we want extrapolation to make a prediction, correct? I need one person to take one more measurement if you'd be so kind. Somebody measure my right hand in inches. This has got 16ths. Let's be as precise as we can. Thank you, Crystal. Appreciate that. Let's go to the wrist, which is, I'm going to guess it's like right about here. Yeah, go ahead and measure that out to my middle
You want
finger.
me to do by the inch or?
Get as much precision as you can, as much as you're comfortable doing.
About 7 3/4.
7 3/4. Thank you, sister. I'm going to come up here. I'm going to give you a little bit of a 7.75. If I plug 7.75 into this model, so 7.75 times 0.82 plus 4.7604, it gives me a predicted 11.2 inches. Crystal, if you'd be so kind, one more measurement. 11.2, that's about 11 and a quarter-ish. Okay? What do we got?
We got almost 12.
Almost 12, 11 and 3/4.
Yeah.
So our model's broken, correct? Wrong. Our model is an average. I want you to take a look over here. See those two values right there? They're the high and low estimates. Here's the deal. Whenever you try to extrapolate, Nick, this goes back to your question of 20 minutes ago. I apologize for making you wait so long. You said, we're interested in making predictions. So yeah, we're interested. If we can measure my hand, can we predict what my forearm's going to be? So when we did, we measured it. The model said it should be 11 and a quarter. Crystal measured it, it's 11 and 3/4. Well, that's off by half an inch. That might not be acceptable, depending on what you're talking about. But that popped out value is the average response. You have to put what's called a margin of error on that because it's an average response, not an exact response. These are the two endpoints of what are called the margin of error. This is the lowest it could be and the highest it could be. Here's my question for you guys. Here's the problem. Crystal said my forearm was almost 12 inches. This right here, 12 inches is not in here. It's bigger than even the highest value. What does that tell you about me?
You're a freak.
I'm a freak. Thank you. I was going to say I don't fit the model, but thank you, Crystal, for saying it much more colorfully.
Yeah, but if you plug in the 7.75 and multiply it by the...
I'm not saying I can't use the model.
Okay.
The question is, should I use the model on me? Maybe I don't fit the model. You see what I'm getting at? Maybe I should throw my data point in down there at the very bottom, recalculate the model, and go measure somebody with a less freakish forearm, maybe, or something along those lines. Fair? Good? Yes? Okay, that's linear modeling in a nutshell, friends. That brings us to the end. Fingers crossed that it's somewhat warmer than today on Wednesday, because we'll take us outside and measure on my bike. We'll see how that goes. If it's crappy and snowy, I'll think of something else. But for Wednesday, two things. Well, I guess three, technically. But let's talk about that. Number one, there is a quiz due for Wednesday. Feel free to turn it in next Monday. It's a linear modeling quiz, which is essentially on the stuff we're doing right now. If you need more time, because we want to go over homework questions, feel free to turn that in next Monday. Fair, that's number one. Number two, what are you definitely bringing on Wednesday? Exam corrections, yes. Rated A coupons, read it carefully. Number three, bring questions on linear modeling homework for Wednesday as well. Okay? That's just the next homework step. Okay, doke? And Andrew, again, I'm sorry about that. Completely missing the friggin' Y intercept. I was focused so much on the slope. I'm focused so much on the damn slope. It is.
I wonder if
It's okay.
you know, NASA, when they do the space.
Exactly. They make everything fit.
Yeah, so I wonder.
Oh, God. Well, the thing about that is those are astronauts. I guarantee their dimension's a little bit differently. I would think. It's such a small sample compared to the general population. They have to pass all these physicals to get in.
Right, that makes sense.
Which probably weaves them down even more, and which makes it even more for them. They probably have more precision in their measurements.
Once you add in that y-intercept, it actually gets that correct ratio closer to 1. Because it's not really a 1-to-1, because you have to add in 40.
Right, the division is almost 1-to-1. I gave you that in my head. Well, I'll play with it and get back to you guys on the quiz. That'll be fun.